So we are going to talk about Culmann's method for active earth pressure. In this one, we are going to deal with the active case. So under this case, we are going to deal with granular. We are going to deal with granular soil, where C is equal to zero, what we call cohesionless soil. Also know that the Culmann's method is a graphical solution to Coulomb. It's a graphical solution to Coulomb. It's a graphical solution to Coulomb's theory, right, or to the Coulomb's method. Now let's make some analysis. So in doing this, let's say I have a retaining wall. I have a retaining wall this way. The vertical back of the retaining wall makes an angle of theta with the vertical. Then the backfill makes an angle of, say, the backfill makes an, let's say, makes an angle of alpha with the horizontal. Now let me call here A, let me call here B. The active pressure will be acting in this direction. Will be acting in this direction. It will make an angle of, it will act with the normal. So it will generate a normal force, right? A normal force and a normal force and a tangential force. Now note that this active pressure PA, this active air pressure PA, this force, the lateral force PA is going to be generated at an angle of delta, at an angle of delta, right? So now, what you have to do is you will have to draw, rescale this thing graphically in order to calculate for your EA. So we'll go through a series of steps. So the first step thing we are supposed to do, we are supposed to, let me call this side for. The first thing you're supposed to do is to draw a line, extend this line. So we are going to extend this line, right? Let me extend this line and call it. So I'll extend this line and call it, let's say, OD. OD. Now, I have to draw a trial wedge, right, passing through this side. So let's say at a certain angle, the trial wedge I'm going to draw over here should make an angle of phi with this horizontal line. Then again, I'll draw an angle, another line OC that will make psi, an angle of psi, right, this way. The next thing you're supposed to do is to draw several trial wedges. So let's say trial wedge 1, of which I call A1, trial wedge 2, of which I call A2, let's say trial wedge 3, of which I call A3. The number of trial wedges to draw when it's more mean that you're going to arriving to a more accurate answer. The next thing you're supposed to do is to calculate for the width of these trial wedges. Calculate for the width of these trial wedges. And note that the width is simply the volume, the volume times the unit weight. And this volume can be represented as the area times a certain height times the gamma. And this H we are using per unit weight. So 1. So our weight finally becomes the area times 1 times the unit weight. This is simply the area times the unit weight. So you find the area of the respective triangle, then multiply by the unit weight to get your area. Now in doing this, after finding your weights, so you find the weights for each triangle, the weights of each triangle. Note that the first triangle, so the triangles over here are AOA1. So A here, OA1. The second triangle is AOA2. So A here, O here, A2. So this whole thing forms the triangle for the second one. The third triangle also starts from here and ends here, right? That's the triangle. code. So we have AOA3 for the third triangle. Now, after doing this, you have to establish a certain scale. After finding your weight, you have to establish a certain scale. You choose a load scale such that OA1 in centimeters is equal to the weight in kilonewton over the scale in kilonewton by the scale in centimeters, by the scale in centimeters. After getting your, so you do that for each of the weights. So after doing that, you have to come and plot this OA value in centimeters on the line. So let's say you get OA1, OA2, and OA3. You plot OA1 on the line, let's say maybe slide here, OA2 here, and let's say OA3 here. Then you draw lines through them that are parallel to this OC line to touch this OB line. So you draw a parallel line this way, another parallel line to this. They should be parallel to this. After doing this, you draw a tangent to pass through, a curve to pass through these lines. You draw a curve to pass through this line. The next step is to draw a tangent to the curve that is also parallel to the OB line. So you draw a tangent, right? A tangent to touch the curve. And the tangent touches the curve at this point. The tangent touches the curve at this point, right? So what's expected of you is to draw, what's expected of you, so let me draw the tangent very well. The tangent touches at this point. What's expected of you is to also draw another line passing through the points of tangent C. And it's also parallel. So you draw another parallel line this way. They name that side, say A, A, A. And let's say here A prime, right? So now the next thing is supposed to draw a line passing through this point. So you draw a line from the origin to pass through this point here. They name that A prime. So now note that your failure word is the OA prime. So the word will feel at A prime, right? In order to find your PA, you measure this line, this AA prime line, this AA prime line. Let's say you measure, assuming you measure this AA prime line. So you measure this AA prime line, then your PA will simply be your PA will simply be the the load scale. So you multiply the load scale by the distance. So the load scale by A prime. The distance you measure here, you multiply by this load scale. So then you find your PA, right? Now, the next thing, so note that when you're finding the area for the AOA1, the area for the first one is this, the area for this, the area for the second one is the whole of this, right? And the area for the third one is the whole of this. Okay, now let's take an example. Let's take an example, then you understand it better.
Gone through the processes in using Culmamm's method for in finding the active earth pressure, and we established the fact that this is just a graphical solution to Coulomb's method for granular soil. That's when the soil C has the soil is cohesionless, where C equals 0. We've already established the processes you go through. So this is an example. In this example, we've been given theta being the angle the backfill mixed with the horizontal as 10 degrees. We've been given, sorry, that's alpha. We've been given theta, that's the angle the backfill, the vertical line over here. Yes, so the angle, the retaining wall, the sliding side of the retaining wall mixed with the horizontal. We've been given the height of the retaining wall. We've been given the unit weight. We've been given our phi as the angle of friction, angle of friction as 30. We've also been given every parameter, and we are asked to find the active pressure on the retaining wall. So in doing this, we first have to, so we initially I told you that the Coleman's method is drawn to scale. So whatever you are going to do should be drawn to scale. So let's proceed. So the first thing you're supposed to do is to establish a scale for this diagram since we are going to draw to scale. So you first of all measure they say the height given over here is 7 meters. So you measure the height. I'm using pencil, but I should be using pen instead. I'm using pen, you should be using pencil. So the height over here is 6.3 centimeters, right? So meaning that my 6.3 centimeters is equivalent to 7 meters. 6.3 centimeters is equivalent to 7 meters. Then again, meaning that 1 centimeter, I'll just divide this 7 meters by 6.3 and I'm getting 1.111 meters. So this is my scale. This is my scale. So note the questions down, then let's proceed. So after establishing my scale, meaning that I have to redraw this whole shape again to scale. I have to redraw this whole shape again to scale. So let me just position this here for it to be clear enough. Okay. So now the first parameter, I'm going to draw the height of I'm drawing this whole thing to scale. So when I measured, it was 6.3. So accurately drawn, I measure 6.3 6.3 centimeters. That's equivalent to my 7 meters. So now that I want to draw this angle over here, so I just go ahead and do this, right? Then I measure the angle over there is 20 degrees. So I measure 20 degrees. So this is the 90. So when I go this, so 10, 20. So my 20 degrees is here, 20 degrees. Then I just draw a line to pass through the 20 degrees. So now I've drawn my retaining wall. I've drawn my retaining wall to scale, right? So since this part is A, this part is B. Again, here is also A, here is also B. Then the height of the retaining wall is simply, so from here I have 6.3 centimeters. Are you getting that? Then I have my angle over here to be 20 degrees. The next thing I have to draw is to draw this angle the backfill makes with the horizontal and was given as alpha, which is 10 degrees. So in doing that, again, I measure 10 degrees from this aspect. So I put it on it this way, put it on it this way, right? Then this is the horizontal, so 10, from 0 to 10. So this is 10 degrees. And I just draw a horizontal, a line, a straight line passing through that angle, right? Straight line passing through that angle. So this line is my 10 degrees line, my 10 degrees line. Now, the next thing I'll have to do, so after doing this, so now finally I've redrawn my retaining wall to scale. So I can go ahead and go through the processes we went through initially. So the first thing I have to do is I have to draw a certain line. So let me call this one, let's say O. Let me call this side O. So then I have to draw a certain line, say OD, such that is OD lies on the base of the horizontal. So I just extend this line this way. So I name it OD. You can name it anyhow you want. So I'm naming it OD. So OD. The next thing you do is to draw your failure wedge, right? You should draw your trial failure wedge. Your trial failure wedge. So let's say I'm going to draw a trial failure wedge OB, just as I explained initially. So in doing that, you are supposed to use the angle of, that's the phi. So we are going to use this phi angle that was given as 30 degrees. We are going to use that. So I put my protractor here again. I put my protractor here. Then I measure 30 degrees. So this is 10, 20, 30. I measure 30 degrees this way. Then I draw a line to pass through it. I draw a line to pass through it neatly this way. Right. Now, so I simply name it, let's say B. Right? So that's my failure wedge. Now I have to also draw another line, let's say OC. And OC makes an angle of 52 degrees with the OB line. So I'm going to supposed to draw an angle phi, just as I showed you initially. And this phi is supposed to make an angle of 52 degrees with this particular line. So first of all, I have to calculate that phi. And the phi is the psi is giving us 90 minus theta minus delta prime, right? So I have 90 minus, what's my value for theta? My value for theta is simply 20 degrees minus my value for delta is simply 18 degrees. When I compute this, I get 52 degrees. So that was why I was saying that this phi is supposed to make an angle of 52 degrees with this. But you have to first compute to see if the value. So let's say theta was 10 and delta was 10. That's going to be 20. So 90 minus 10 minus 10, then I'll be getting something like 70 degrees. So meaning that the psi angle I'm going to draw should make an angle of 70 degrees with this. But in this case, it should make an angle of 52 degrees. So again, I put my protractor this on it this way. This is how you are going to put it on it this way, right? So realize that from here to here is 30, this is 40, this is 50, so 52, this is 52. Then I just draw a parallel line, a line to pass through it this way. And that gives me, let's say, OC. So I know that from here to here is 30 degrees, and from here to here is 52 degrees. The next thing I'm supposed to do is to draw several trial, let's say, wedges. Okay, trial failure wedges. We're going to draw several trial failure wedges of your own. It should be of your own choice. So yes, the weight, it should be of your own choice. But in here, I'll advise you to use establish this in equal intervals. So I'm going to use equal intervals of 2. Okay, in order to make my work simple, I'm going to take equal intervals of 2. So let's say, and you should, for the more trial wedges you draw, the more accurate your work is going to be. So I'm going to use, for illustration's sake, I'm just going to use 3 trial wedges. So let's say 2 centimeters here, another 2 centimeters here, another 2 centimeters here, in order for my work to be simple. Then I just draw a line to pass through them in order to form a triangle. So I have one failure wedge this way. This was the next 2 centimeters. Another one this way. This was the next one. You can draw as many as you want. The more you draw, the more it becomes accurate. So you know that the distance from here to here is what? 2 centimeters. And it's the same from here to here and from here to here, right? So you can draw as many. So I'm going to name this side A1 and this side A2, right? Then I name this side A3, A3. Now, the next thing you're supposed to do is to find the weight of each of the trial failure wedges. The weight. You have to find the weight of each of the trial failure. So this is the first one, this is the second one, this is the third one. By in doing this, in order to make your work simple, I urge you to draw a table. To make this simple, there's the need to draw a table. So let's say a simple table where you have your triangle over here. You have your parameters here to be parameters. Then you have, let's say, area in meters squared. Area in meters squared, the parameters in meters. Then you have, let's say, another aspect for weight, right, in kilonewtons. Then you finally have an aspect for OA in centimeters, just as explained, I've explained already. Just as I've explained already. Right. So now, the first triangle I have over here, the first triangle I have over here is AOA1. So AOA1. Then you find the parameters for A. Since it's a triangle, you'll be having a breadth and a height. Okay, we having a breadth and a height. Now, the next triangle is AOA2, also having a breadth and a height. The next triangle being AOA3, also having a breadth and a height, right? So this is all what I have. But if you have more, you'll be having AOA4 and others. So I have to write my parameters. So when I take the first triangle, AA1 is my breadth. When I take the second triangle, I have from A to A2 as my breadth. The third one from A to A3 is my breadth. But before that, we realize that this is in centimeters. So I have to do certain conversions to change it to meters using the scale we established. So we established that 6.3 centimeters is equal to 7 meters. Is equal to 7 meters. What this means is that what this means is that 2 centimeters will equal to, let's say, x. Then I have what, 7 by 2 by 6.3, and this gives me 2.22 meters. So this, so meaning that in essence 2 centimeters is simply 2.22 meters per my scale. So now when I take the first triangle, which is AOA1, my breadth is from here to here is 2 centimeters. So my breadth is simply 2.22 meters. Can you see that? The next triangle is A2. So AOA2. So my this thing becomes 2.22 plus 2.22. And that simply gives me 4.44. So my next breadth is 4.44. Then again from here to here, I have 2.22 plus 2.22 plus 2.22. That gives me 6.66. So I have my breadth again to be 6.66. The next thing is for me to find my height, my respective height. In order to find the height, you find a perpendicular distance. So what you do is you draw another line that is parallel to this one. The let me call here, let's say P. That is parallel to the AP line, but passing through O, right? So this one makes an angle of 10 degrees with the horizontal. So again, I draw an imaginary 10 degrees an imaginary 10 degrees here. So let's say 10 degrees will be here. I draw an imaginary, for this one, let me use a pencil. An imaginary 10 degrees line this way, right? And it's parallel to this particular line. The next thing is that I draw a perpendicular line. So I just put this one is this way, the origin and on the line. Then I draw a perpendicular line that's 90 degrees. So I measure where the 90 is. So the 90 degrees is here. Can you see that? I just put it on it this way where I drew my parallel line. The 90 degrees is here. And I just draw a line passing through to touch the AP line. So I have this, making an angle of 90 degrees over here. So now this is the perpendicular height for all the triangles. So in order to get the height, I simply measure this particular height. Then I get 6.4 or 6.4 centimeters. Again, I do my conversions. So if 6.3 is equal to 7, 6.4 will be equal to what? So I have my x to be 7 by 6.4 divided by 6.3. And that gives what? So 7 by 6.4 divided by 6.3. That gives 7.11 meters. So the perpendicular height for all the triangles becomes 7.11 meters. So I have 7.11, 7.11, 7.11. Now from here, you just do computations. So you find area. You know that area is simply half times base times height. So we have half, sorry, we have half times the base, 2.22 times the height, 7.11. And that simply gives 7.8921. So we have the area 7.8921 in meters square. Then you do same for this. I just simply change this I to 4.44. That gives 15.7842. 15.7842. And I do for the next one. Oh, I've erased it. So let me just 6.66 by 7.11. That gives 23.6763. That's the area. The next thing is to find your weight. So just as I explained, the weight is simply the weight is simply the area times your unit weight. The area times your volume times the unit weight. Okay. So the volume is also the area times a certain weight times gamma. So over here we are finding per unit weight, which is 1. So I simply have area times gamma. Then I've already computed for my area, so I multiply by gamma, and gamma is already has been given in the question as 17 kilonewton per meter. So we're giving gamma as 17 kilonewton per meter cube. So meaning that I'm just going to multiply these values by 17. So I have 7.8921 by 17, 7.8, sorry, 15.7842 by 17, 23.6763 by 17, right? So in doing this, for the last part, I get 402.4971. Then for this part, 15.7842 by 70, I have 268.3314. Then 7.8921 by 17, 134.1657. Right. The next thing is to find your OA. So over here, you'll be getting OA1, OA2, and OA3. Now, just as I explained what the OA was, I'll still highlight on it again. So the OA is simply the weight in centimeters. The weight is in centimeters. So but before you so meaning that you have to choose a certain scale. So per my weight I have to choose a certain scale. So let's say the scale I'm going to use is I'm going to use a scale of per the values I have here. The values I have here, I'm going to choose a scale of say 1 centimeter is to 100 kilonewtons. 1 centimeter is to 100 kilonewtons. Then what you do is that you convert all of this to so if 1 centimeter is to 100 kilonewtons, then let's say y will be equal to x. Okay, so now we are going to find y. We are going to find y. Since the x values have been given, we are going to find y. So let's make this the sample. So we have, let's say x will be equal to 100 kilonewtons. 100 kilonewtons. Sorry, y will be equal to x over 100 by 1 centimeter. X over 100 by 1 centimeter. So I'll convert all of them. So the first one, I'm just going to get this OA1 is going to be 134.1657 over 100 by 1. And this simply gives 1.34 centimeters. The next aspect, so I have 268.3314. I divide by 100. I multiply by 1. This gives 2.68 centimeters. Then the last part, 402.4971 over 100 by 1. And this also gives 4.02 centimeters. So I go ahead and plot these values on the graph, on the sketch, the graphical method. So I have this, okay, right? So the first value, the OA value I have over here is 1.34 centimeters. So I plot this OA on the OA1 line. So 1.34 centimeters. So now I just put my triangle over here, my ruler over here this way. And I measure 1.34. This one, 1.34 will be somewhere. Yeah, so this 1.34, then I plot it there. So I plot 1.34 there, right? Then I draw a, so now let's plot the second one. 082 is 2.68. So that one, so I plot 2.68 on this line, 2.68, so it's 2.5, 2.68, 2.68, so 2.68 here, 2.68. The next one is 4.02. So this 4, 4.02, 4.02. So let's say this 4.02 this way, right? So 4.02. Now, after establishing my point, I draw a line passing through this point that is parallel to the OC line. So you know how to draw parallel lines already. So because of, I'm just going to draw parallel lines passing through. So, and it should touch the trial filial wedge, which is OB. So I draw a line parallel to touch one here, another one here, then finally another one. This line should be parallel to this OC. It should be parallel to this OC line. Good. Now, so now this is O A. This is A1, A2, and A3. After doing this, you have to draw a line, a curve passing through these 3 points, and from here, so a curve passing through these 3 points. So I have to draw a curve passing through those 3 points. Curve passing through those 3 points, right? So from there, you draw a tangential line to touch the curve, and this tangential line should be somehow parallel to this line. Okay, it should be somehow parallel to this line. So I have my tangential line here, my tangential line here this way. Okay, this is my tangential line. So where the tangent touches the curve, where the tangent touches the curve somewhere here, right? I also draw another parallel line. No, I think it touches somewhere here. I also draw another parallel line to this at that point. So that's becomes some sort of this. Okay, yes. Then I name that side, let's say A, A, A. So now the points at which the tangent touch the curve, I draw a line to pass through that point. A line to pass through that point. And I name it as A prime. A prime. Good. So now I'll go ahead and measure this line. So let me call here A prime. So I'll go ahead and measure this A prime. Sorry, A prime here, A prime. So I'll go ahead and measure this A prime A line, A prime A line, and that gives me that that gives me approximately, let's say 2.7, 2.6, so 2.6 centimeters. So I'm getting a a prime A to be 2.7 centimeters. Now, since this is also an OA, I have to convert it back into kilonewtons, and that will be my the active pressure. So again, I'm going to say that from the scale I chose, I had a scale saying that over here, the scale I chose, I had a scale saying that I should let 1 centimeter to be equal to 100 kilonewtons, right? That was the scale I chose. So meaning that 2.7 centimeters will be equivalent to what? Equivalent to what? So X final becomes 2.7 centimeters by 100 kilonewtons all over 1 centimeter. Then we have our final answer to be, so 2.7 by 100, that gives 270 kilonewtons. Mind you, this centimeter goes for the centimeter. So now the partial force is now 270 kilonewtons. 270 kilonewtons, which is PA, is equal to 270 kilonewtons. This is what is expected of us. And also knows that, meaning what this means is that the trial failure wedge is this OAA prime line, right? So we have the triangle to be AOAA prime, AOAA prime, and it has a force of a partial force, a lateral force of 270 kilonewtons.